Good afternoon. My name is Vivek Kumar Verma. I am an assistant professor in Department of Electrical and Electronics Engineering. Today we will discuss data transmission. Okay, it's at 5. First we see the instruction move RD, RS. This move RD, RS is basically used to move the data from the source to the destination. Here the source can be memory, register, or data, and the destination can be memory or register. So there are various combinations can be made from this all these combinations. So there is no need to cram all the instructions. First, you must only know the corresponding format. I will explain with the example. Move A comma B. So here B is a source register, A is a destination register. So what we'll do, we'll move the content of B register to the accumulator. In the same manner, the second instruction, that is MBI RD comma data. It is same as the move instruction, but it is move the immediate data to the destination, and the destination again it can be memory or it can be any register that is specified in the 8085, which can be this register can be A register, B register, C register, D register, E register, H register, HL register, L register, any register can. Okay, so I will explain with the example. MBI B comma 04H. What does it mean? It will move the 04H immediate value to the corresponding B register. Okay. Now the third instruction is LDA. LDA means load. Load the content, load the accumulator from the given address. This address is basically in the memory location. So I will explain with example. LDA A comma, if I write 2004H, what does it mean? It means 2004H is a location and we are loading the content of this location. For example, if this location is having the value 02H, then this value will move to the accumulator. Okay. Now, next section is LDX B/D register. Basically, both these instructions are same. First is an example of direct addressing mode, another example of indirect addressing. Here the address is given directly, but in this address is given but is hidden in the VC register pair or D register pair. So I will explain with the example. If I write LDAX B. So in case of register pair, always we write a first letter. Like for example, if I take a BC register pair, we have to take B. If I am taking D register pair, then I will write a D. Okay. So BC is having the address. We can take any address. For example, if I write 2006H, then this address is having any value. For example, 02H. This value will move to the accumulator. Okay, so working is same for both the instruction, but in the first case the address is directly given, but in the second case the address is hidden and it is either in the BC register pair or D register pair. Now, next instruction is LHLD 16-bit address. LHLD 16-bit address basically, what we'll do, it will load the HL register pair from the given memory location. But basically, each memory location contains only 8-bit data. But the HL register pair, this HL register pair is a 16-bit register. So from the first view, it will look like that you are moving 8-bit data to the system bit register pair, but it doesn't. Basically, we are moving 16-bit data from the memory to the HL register pair. How it will happen? Let's see. If I write LHLD 2004H, then what will do? It will load from the two consecutive memory, that is 2004H. First it will move from this location the value to the L register. After that, this address is incremented by 1. And if this location is having value, for example, 04H, then this value move to the H register. So in this manner, we are moving the 16-bit value, that is 0204 to the LH register pair. Finally, what will be the have value? We have the value in the HL register pair 04H and 02H. Okay. Now, LXI register pair system bit data. This is the only register, the only instruction that is used to store a 16-bit data to the register pair. So register pair, basically there are how many register pair? We can have a register pair BC, DE, or HL register pair. So we can store any register pair with the system bit data. So I will explain with the example. If I write LXI D. So I already told you that in case of register pair, we only write first letter. Okay, we omit the second letter. So LXI D means LXI D comma. If I write LXI D comma 2004H, what does it do? It will store the value 2004H to the DE register pair. So DE register pair now value 2004H. Okay. So this instruction load immediate value to the corresponding register pair. Now, the next two instruction basically is used to store content of accumulator to the given memory location. So we already see the two instruction LDA and LDX. They are basically loading the accumulator from the given address. But these two instructions store the content of accumulator to the given location. So what we'll do, if I take an example, STA 2006. So what will do? It will store the content of accumulator. For example, if the accumulator is having 04H, then it will move to the corresponding memory location, and the corresponding memory location will be 04H. So it is moving the content of accumulator to the given memory. Now, in the same, we above instruction is an example of direct addressing mode where address is direct table. But in the second instruction, it is same as above instruction, but the address is hidden. Now address is either in the BC register pair or TE register pair. So I will take the example STAXD. So I am writing the first letter of the register pair D register pair as D. So STXD. What it will do? It will store the value of accumulator to the memory location which is stored in the DE register pair. For example, DE register pair is having value 2008. Okay, what we will do? It will store the value of accumulator. For example, the value of accumulator is having 06. Then this 06 value will be stored in this location. Okay. Now, SPHL. Basically, it is very least used instruction in the 8085 microprocessor. But for explanation, I will give some explanation how it works and what is the work of this instruction. Basically, it will move the content of HL register pair to the stack pointer. For example, if HL register pair is having value 2004H, then this value will move to the stack pointer 2004H. Okay. So SPHL basically move the value of HL to the stack pointer. Okay. Exchange. Exchange is having doesn't having any operands. Okay. But what it will do? It will exchange the content of DE register pair with the HL register. How? The E content of E is exchanged with the L register, and the content of D is exchanged with the H register. For example, if the DE register pair is having the value 2004H and HL is having value 4006H. Okay. Now after exchange, if I write a exchange SG, then what will the content of DE and HL register pair? It will be now the content of DE will be 4006H and the content of HL will be 2004H. Okay. Now XTHL. The XTHL is basically exchange. XTHL will be exchanged with the top of the stack. Move the content from the top of the stack to the HL register pair. How it will happen? Let's see this. For example, if the stack pointer is having address 2005H and this location is having value 06H and another location 2006H having value 08H, then what will do? It will move the content. It will move the content pointed by the stack pointer having value 2005H. This value is to 06 to the L register. Okay. So first the value that is pointed by the stack pointer will move to the L register pair, not to the L. Now the value of L will be 06H. After that, stack pointer will be incremented by 1 plus 1, and the stack pointer value will be 2006H, and this value now move to the H register pair. So it will move the content from the top of the stack to the HL register pair. Okay. The next instruction is push register pair and pop register pair in the next slide. So these two instructions is basically used for the stack operation. Now the question is, what is stack? The stack is the area in the read-write memory which are used to store the return address. For example, in a function, when you call a function, so after doing the work in a function, when you return from the function, it will reach to the main program. How it will happen? How will it will retrieve the starting address very left from the very left initially. This return address basically is stored in the stack area. So stack is not used for only that work to store the return address. It can also use to store the value of variables. Okay, so stack is basically used in C language, Python, everywhere. So now we'll see in 8085 how we can use the stack area, how we can store our variables value, and how we can retrieve back it with the help of push and pop instruction. So first instruction is push register pair. So stack is always defined at the top of the stack, top of the location, and its address is defined by stack pointer. For example, if stack pointer is value 2099H, okay, and push register pair means if you are want to move the content of any register pair to the stack location. So I will explain with the example. If I write push B, then push B, what does mean by push B? It will push the content of BC register pair to the stack. How it will happen? First of all, stack pointer will be decremented by 1. The SP minus 1. The address will be 2098 at 8H, and the content of C, content of C register pair. So the content of C, for example, the content of C is 04 and content of B is 06H. So first of all, the content of C will be stored in this location. Okay. Now stack pointer again decremented by 1, and the next address will be 2097H. After that, this value 06 will be stored on this. Okay. So in this manner, the value of BC register pair will store on the stack area. Now, if you want to retrieve back this value in the BC register pair, then we have a instruction pop register. How it will work? For example, if I write pop BC, I want to retrieve back the value of BC register pair, which are stored in the which we store in the previously in the stack. How we can retrieve it? We all know that we already stored the value of BC register pair, that is 04 and 06. So 04, it is in the 2098H, and 06H, it is in the 2097H. 97H, and currently the stack pointer is having value 2097H. So when we write pop B, it will retrieve the value of BC register from the stack. How it will happen? First, the value pointed by stack pointed at 2097H, it is having 06. It will move to the B register. Okay, so it will move to the B register. After it, again, stack pointer will incremented by 1, and this value move to the C register pair, and again the stack pointer will be incremented by 1. Now finally the stack pointer is having value 2099H. Okay, so in push, first we decrement, then we push the value, but in pop, first we retrieve, then increment. So it's a very confusing type. So student always make mistake. So please make it point. In push operation, first we decrement, then push the value, and in pop, first we retrieve it, then we increment them. Okay, increment the value of stack pointer. Now, after there are two more instructions in data transfer type instruction, in and out. These two instructions are used to move the data, from the input and output device. How it will do? If I take example, in 04H, it will move the value from the device having the address 04H. For example, it is having value 02H to the accumulator. Okay. Out 8-bit port address, what will do? It move the value of accumulator to the device whose port address is given. So I will explain with the example. Out, if I write out 06H, so what will do? It will move the content of accumulator. For example, it is high value 04H to the device whose address is 06H. Okay. So this is all about our today's instruction. Thank you.